for posterity. Or at least for you guys. Alright, so I need, for this one, since it says find the points of inflection, all discontinuities in the open intervals where it's concave up and down. Alright, so I need the second derivative, don't I? So I can't get the second derivative without the first derivative. So y prime is 3x squared minus 6x. So y double prime is 6x minus 6. Alright, now, what do we need to do with the second derivative? Set it to 0. So 6x minus 6 equals 0. Add 6 to both sides. 6x equals 6. Divide by 6, x equals 1, which tells me that I'm going to do a sign test on the second derivative where my point of inflection is at x equals 1. Now, what would be a good test point here? Alright, t equals 0. Here would be t equals 2. So, at t equals, x equals 0. Hold on. Y double prime is 6 times 0 minus 6, which is negative 6, which is negative. Y double prime for x equals 2 would be 6 times 2 minus 6, which is 12 minus 6, which is 6, which is positive. So my intervals were concave up where? One to infinity. We're concave down negative infinity to 1. Now, for the point of inflection, I know it's at x equals 1, so I know it's at 1, but what's my y value? How can I figure out my y value? Plug it into the original function, absolutely. So I would go y is equal to 1 cubed minus 3 times 1 squared plus 4. So y would be equal to 1 minus 3 plus 4, which would not be 0. 1 minus 3 is a negative 2, plus 4 is 2. It's okay. No worries. And there's your point right there. Right there. There's your point of inflection. Now looking at the graph, does it kind of make sense that that looks like it's the point that kind of stops it from being concave down right here, because it's concave down here and it's concave up here, and that point seems to be smack dab in the middle of both of them? That's what the point of inflection is. It's a point that's smack dab in the middle of the concavity. So that one kind of makes sense. We probably could have looked at this picture and gotten our interval, because that goes forever. So negative infinity to 1, and then 1 to infinity would be the two intervals, and that point looks like it's the dividing point. But you should never, ever, ever, ever trust the graph when you have the function, and do your tests on the function, because the tests on the function are going to get the correct answer 100% of the time. Yes? Your critical values are going to be here. That's a critical value. and here's a critical value. Because critical values are for minimums and maximums. So that's a relative minimum. That guy right there is a relative maximum. So that's where y prime is equal to 0. Test points are just points that we need when we're doing a sign test to determine whether or not it's negative or positive. So we don't actually pick critical values for those. The critical value is going to tell us like this. The point of inflection is concavity's critical value. We just already had a name for critical value, so we had to pick something different. So we used point of inflection. The critical value is the thing that separates the intervals. It's the endpoints of the intervals. The point of inflection are the endpoints of the intervals. And we have to figure out what's going on inside the interval. So, Sean. For this guy, you could have. That would have worked. But I would have factored. 3x times x minus 2. And set that equal to 0. And get 3x equals 0, so x equals 0, and then that x equal 2. So those would be critical values. And that's for y prime. That would have been the easiest way to do it. If it was one more step, the first thing I would suggest is see if you can factor it, because factoring is easier than the quadratic formula. But the quadratic formula is going to get your answers 100% of the time. So if you need to use that, use that. All right, you have the rest of the time to work on these problemos, and we will talk about this stuff tomorrow and go over more examples.